I'd like to move on to 62 on page 155. And that is a different type of inequality. And the name of this inequality is compound inequality. Compound inequality. It's actually two inequalities put together. If you notice, this is one inequality, and this is the other. So we call it a compound inequality. How do I solve a compound inequality? Any suggestions here, or what do you think if you remember? What should we do?
Take care of the middle first.
Say it again.
Take care of the middle first.
Of the middle?
Yeah, like.
Yes.
Distribute 2x.
If you want to distribute, we can distribute. That's fine. So let's distribute. So that we have -5 less than or equal to.
2x.
Oops. Very good. 2x plus 8. And now, what are we going to do to all three sides at the same time?
Subtract by 8.
Very good. Subtract 8 from all three sides. When I subtract 8 from the left, I get. When I subtract 8 from the middle, and when I subtract 8 from the right, perfect. Final step.
Divide by 2x. Almost done.
I can never divide by x.
Divide by 2.
Ever divide by x? We cannot. Yes, all I need is to divide by 2. Perfect. So -13/2 less than or equal to, and less than. Excellent. In interval notation, 0 in the middle, -∞, infinity. -13/2 is roughly -7. Well, it's not, but I'm going to represent it right here at -13/2. And 0, since it does not have the equal symbol, will be an open point. So the bracket will be at -13/2, and the parenthesis will be at 0. And this is the interval notation. -13/2, comma 0. X in this. Okay, this type of next problem will come up, and I want to make sure that you understand or remember that the guessing method is not acceptable. So if I show you a method in class and you know a different method that you prefer, use your method. But the guessing method is not a method, so I will not be able to give points for just plugging in some numbers with a calculator and getting the answer that way. So the guessing method is not acceptable. So on page 155, let's look at a word problem, problem 70. So a surprise retirement party is planned, and they have a total of $860, and they collected this for the event. This reception hall charges a cleanup fee, $40, and for $15 per person for drinks and light snacks. Find the greatest number of people that may be invited and still stay within the $860.
So that's 15x plus 40.
15x plus.
40
Very good.
equals 806.
Careful. Very good. We have to stay within the budget. We don't necessarily want to exceed. We don't want to exceed it, but it can be 860 or less. So 860. Perfect. So if you write this inequality on such a problem, then I know that you know what you're doing. If you don't write this inequality and you come up with the answer, I cannot give credit. So you have to show you mathematically what the problem is telling us, how we translate it into a mathematical form, and then say, oh, okay, this is the inequality that represents the scenario, and here's how I solve it. Okay? So just saying on the side, oh, I checked with the calculator. I punched in 5. I punched in 10. I punched in 25. I punched in 50. No, I can't give credit for that method. Okay? Perfect. So what should I do first? Very good. Excellent. For 15x less than or equal to. Very good. And finally, I divide both sides by 15, so I get x less than or equal to. And now I can take my calculator, and I do have, I'll show you with the calculator. I have a 84 Plus software here that they installed for us a long time ago, not just now. Oh, it's valid. Okay. So we have 860, and we divide this by 15. And I'm not going to say 57.33 people, and I cannot round up 57 to 58 because I will exceed the budget. Yes?
Do you divide by 860 or 820?
I'm sorry. I didn't mean that. I didn't even look. Of course. My apologies. Of course. Sorry about that. So I'm not going to round up to and say it's 55 people, because I can't. 55 will exceed the budget of 860. And I cannot say 54.6 people either, right? So I'm going to say 54. But this cannot be written in an interval notation when it comes to people. So writing it like this, it's really incorrect. Why? Because as we know, this represents everything here, including 1.395. But can I have 1.395 people? No. So I have two options of writing the solution. One option is plain English, which I accept. At most, 54 guests. That's perfect. Or you can say, or present mathematically in the following way. 0, 1, 2, 54, which means the same thing. But I cannot use an interval notation. This will be incorrect. 0, 54 will be incorrect because this includes also 1.39, which will be incorrect. So whichever method you prefer, I'm fine. So this is the roster notation. It can be 0 if nobody wants to show up. That's fine. But they cannot exceed 54 because we will exceed the budget. Any questions? Any questions? So this was just a refresher on 2.8, which was from part of 011. So I'd like to move on to 9.1. Do I still have time? Yes, I do. Okay, 9.1, that's chapter 9, that deals with inequalities and compound inequalities, and 9.1. We already know one compound inequality. Let's solve another. Let's say 32 on page 557. And then I need to explain two concepts here. But I like to practice one more. Okay. So here's a problem on page 557, problem 32. Is this a compound inequality? Yes. It's made out of two inequalities. This is one inequality, and this is the other. So then, what would you recommend first? Again, the same idea. We want to get to x. We want to solve for x. So what would you recommend? And never be afraid to be wrong. We all make mistakes, which is fine.
Multiply by 8.
So we want to multiply both sides by 8. Yes. We want to multiply both sides, all three sides by 3. We want to, oh, yes, you thought it was, oh, I'm so sorry, you're right. So it is 3. So we want to eliminate this. In order to eliminate a denominator, we will multiply all three sides by 3. So the left-hand side gets multiplied by 3. The middle part gets multiplied by 3 over 1 because it's a fraction and it's easier to see it like that. And the right-hand side is multiplied by 3. Now, I did not say anything about cell phone policy. I see when you look down, I see under the table, I can see everything. Not everything. I'm kidding. But I'm kindly asking you, if you have something that is urgent, I understand. It's okay. Just go outside. I always have the door open so nobody gets bothered by opening and closing the door. So go outside, do what you need to do, and you come back. Okay? So if that's the case, I'm encouraging you to take a moment and deal with it. Okay, so the left-hand side. Good. Less than. Careful. Negative 2x plus 5. Less than or equal to. Right. So what you did, although you didn't tell me, but I know you did that, you simplify this 3 from the top with this 3 from the bottom, and this is what you were supposed to do. Simplify the fraction or the multiplication or the product first before you distribute or before you multiply. You make your life much easier. And you don't have to distribute because 3 and 3 will go away. Perfect. And now we know what to do. What is the next step? Yes. So I'm going to subtract 5 from all 3 sides. The left-hand side is? The middle is negative 2x, of course. And the right-hand side will be? Excellent. Now, as the final step before I write the solution of this compound inequality, I will have to divide all 3 sides by? Okay, when I divide the left-hand side by negative 2, I get 17 halves. Very good. When I divide the middle part, I get x, because that was the purpose of dividing by negative 2, just to get x. And the right-hand side is negative 2 divided by negative 2, which is 1. But now, exactly. So please write yourselves a note in case you forgot this rule. Note, when dividing or multiplying an inequality by a negative number, remember to switch the direction or the inequality symbol, whatever you want to write, the inequality symbol. Let me read this one more time to you. When dividing or multiplying an inequality, I should say maybe both sides of an inequality or all 3 sides, by a negative number, comma, remember to switch the inequality symbol. When dividing or multiplying an inequality by a negative number, comma, remember to switch the inequality symbol. So from less than or equal to, I have to switch it to greater than or equal to. Again, the same thing. You notice that it will make no sense to keep it in this way. It will make no sense because 17 halves less than x less than 1. 17 halves is not less than 1. 1 is less than 17 halves. And now when I write the solution, I have to read it in order. So the order in this case will be, if you can, I recommend rewriting it, this. And then if you draw it or not, it doesn't matter. It's 1 comma 17 halves in interval notation. X in the interval between 1 and 17 halves. Now, coming back to the original inequality, how do I read this? I read negative 4 is less than or equal to negative 2x plus 5 over 3 and less than or equal to 1. So there are 2 types of compound inequalities. 2 types of compound inequalities. Here's one. One connected by the conjunction and the other one by or. They are totally different. The and I will put in parentheses just for you to remember, is strong. It means intersection. The or is weak. It means union. And I'll explain in a minute what I mean by strong and weak. Strong is a double condition. Weak, one or the other. And this has to happen and this has to happen for me to be happy. If this or this, I'll be okay. See the difference? So and is strong. This and this must happen at the same time for a third event to happen. The second one is if this is okay or that is okay, it's good. Okay, that's the difference. So now let's look at some situations and understand how we address the and how we address the or. So first let's look at sets. Then we will look at intervals. And then at inequalities. So three different things. First we're going to look at the intersection and union of sets. Then we're going to look into intersection and union of intervals. And then we are going to apply this in inequalities, solving inequalities. Okay, so here's a set. I'm just making it up. 0, 1, 3, 10. That's set A. I have a set with 4 numbers. It's called A. I have a set B with 5 numbers. 1, 5, 7, 11. Let me put 10 also, and 11. Let's say 5 numbers. Now, I would like to determine the union. Union has this symbol, U. So the union is another set. The union of A union B. That's another set, this third set, in which I'm happy with anything. Either what is in A or what is in B. Those can be in the union. So all I have to do is just list all the elements and write them only once. I cannot write them twice, because if I write 1 twice, it doesn't mean that I have an extra element that is 1. I still have just 1 element. So this is 0, 1, 3, 5, 7, 10, 11. That's the union. If it's here, it should be here. If it's here, it should be here. Now the intersection has this symbol. The upside down wheel. That is very strong. That says if it's here and here, then it should be in the intersection. The union, bless you. The union, one more time, says if it's here or here, it's going to be in the intersection. It's okay. But the intersection, in the union, in the intersection is very strong. So the elements in the intersection must come or must exist in both. In both sets. So is there anything that I can write as the intersection of A and B? 1 and 10. Very good. Here's another example. Let's say I have A, which is 0 and 1, and I have B, which is 3, 5, and 7. Can anyone give us the union?
0, 1, 3, 5, 7.
Can anyone give us the intersection?
No.
Nothing. That's the answer. So first of all, you can write nothing. You can write this with nothing inside. No element can be put inside. Or, here's the third option, the Greek letter phi. All these three mean empty or the empty set. Nothing. I don't have anything. No element. Not even 0. Nothing. It's empty. Nothing is empty. This is the symbol for the empty set. So this is how we address union and intersection of sets. Now let's look at union and intersection of intervals. So let's say I have 0, 1, union with 5, 10. Okay, let's take a look. Here's 0, here's 1, here's 5, here's 10. So 0, 1 is this interval with brackets. 5, 10 is this interval with brackets. So this must be the union, and there's nothing I can do to it. This is it. The union of these two sets is them putting them together, exactly like here. Imagine this was set A, which is not the case, but I'm just comparing. This is this, and this is this. And when I create the union, all I have to do is just put them together and write them only once. That's the union. What if I want to change this into the intersection? What will you say? Which are the common elements to these two intervals? Where do they overlap? Which elements are in here as well as in here? None. So the answer would be nothing. Nothing. The intersection does not have any element. Or you can write that, or you can write this, or you can say nothing. In this case, we prefer these two, but for the sets is okay. Here's another example. So let's say negative infinity 0 intersection or intersected with negative 3, 10. And you can say, well, I don't see this. Show me. First, graph it, and I'll do that. 0 in the middle, negative infinity and infinity. And I will represent the first set clearly to the left-hand side of 0. And I will represent the other interval between negative 3 and 10. So here's negative 3, and here's 10. And I would like you to give me the intersection of these two intervals. What will you say? What should I write?
0, negative 3.
We read from left to right, so we have to, yes. Can you say it again? You're right.
0 to negative 3.
But I have to start from the left.
Oh, negative 3.
Very good. Negative 3, 0. That is the intersection. Now I'm changing the question. Any questions on the intersection? Are we in agreement? Okay. Yes? Go ahead. Yes? Any questions, please? Okay. So now I'm changing, and I want to determine the union. Negative infinity 0, union, negative 3, 10. What would you say? Let me create a scenario before you answer this question. We have a party, and imagine that negative infinity to 0 is what you bring to the party as the, I don't know, potluck. You're bringing all sorts of foods, and they are included somewhere between negative infinity and 0. I also come to the party, and I bring in negative 3 to 10. So this is the food I bring in. It's somewhere between negative 3 and 10. And now we have everything sitting here on this table, laid on the table. What can we share? What do we share? Not what we have in common. Oh, you brought lasagna and I brought lasagna. That is something that...
I'm sorry, I think I'm in the wrong class.
Which class are you looking for?
Sociology.
Definitely in the wrong class.
It said 401, but I'm not.
This is 401.
Okay, I'll look again. Thank you.
Sure. So it's not that you brought, I don't know, Pepsi and I brought Pepsi as well. So this is what we have the same, identical. No, it's everything is on the table. What can we share? All of it.
Negative of
Negative infinity till? Indeed. That's all I wanted you to say. Indeed. Negative infinity to 10 is the union. So if it's in one of the sets, it will be in the union. The intersection says it must be in both to be in the intersection. That's why I call that a strong relationship. It requires two conditions to be fulfilled. Here and here, then it's in the intersection. But for the union, if it's here or here, it should be in the union. Perfect. So having all this known already, we are ready to choose from page 558. Because we talked about union and intersections of sets, we talked about union and intersections of intervals, and now we're talking about how we apply the union and this intersection to inequalities. And let's start with, let's say 50, what am I looking at? No, let's say 63, one out. Feel free to choose if something catches your eye. So 3x plus 2 less than or equal to 5, or 7x greater than 29. So of course I have to do what first before I even look at that or, whatever that is, whatever it means. So what do I have to do first before I do the or? And by the way, which operation is or? Union. Perfect. Excellent. It is the union, which I know it's not the strong relationship. It's not, okay, if it's here or here, it should be in the union. So what do I have to do first then? Solve the two inequalities. Perfect. I know how to solve. I will subtract 2 or move 2 to the other side. 3x less than or equal to 3. And finally, I will have to divide both sides by 3. So I have x less than or equal to 1. Leave it alone for a moment. Now I have to look at the other one, and what do I do? Perfect. So I have then x greater than 29 over 7, and now I will graph them or not. I highly recommend in this case always graph. I will always graph for you when I explain this. So less than or equal to 1, here's 1. Less than or equal to is to the left. And 29 over 7 is more than 4, a little bit more than 4. So here is 29 over 7, and to the right. Seeing this and thinking of the union, I know what I have to write. So what do I write? Yes, I'm ready. Union. Yes, if it were the strong one, I would have said nothing because there is no overlap. But this is the union. This is if it's here or here, it's going to be in the union. So how do I write that?
You do negative infinity.
Yes.
1, and then union.
Union.
29.
Yes.
7 infinity.
Parenthesis here. I rushed. It's a parenthesis. Very good. This is a solution, and there is nothing else I can write. Is that clear? And I will try to show you every step of the way why we're doing what we're doing. And you could say, really? Where will I see in life compound inequalities? Come on. Well, here's an example right here. On page 559. Well, maybe I should practice more. Let's look at another couple of problems, and then, yes, let's do 65. And then I'll explain and I'll show you examples in which this is extremely useful. Same page, 558. Thank you. Okay. Okay, so here's a compound inequality. What operation with intervals will this result in? Excellent. Intersection indeed. which is not the weak one, is the very strong one that says, they must be in both. Common area. So you can write in parentheses if that triggers your memory. Common area. Okay, so I solved the first inequality. How do I solve it? Yes, negative x is greater than
2.
Very good. And finally, x, yes, because I need to divide or multiply both sides by -1. And then we have to switch the inequality symbol. Is that clear? Is everyone? Okay. So now what do I do here? So leave this alone for a moment. Now the other one. What do I do?
X is greater than or equal to 5.
So 2x greater than or equal to, you are moving 3, perfect, 10, and x greater than or equal to 5. I agree with both. So now let's look at the real line, or the number line. Negative infinity to infinity, 0 in the middle. I will represent less than -2, which is this. Again, notice that I don't care for units. This is just to help us come up with a solution. There's no need to spend time on units, but if you want to be super accurate, you can. And this is 5. And I'm asked to find the common territory or common area, because this is an and. It's an intersection. So if you want to write it, you will write negative infinity, -2. Intersected by 5 infinity, and then you must write the final answer. This is not good enough. And what is the final answer? Nothing. Nothing. They do not overlap. And what would you have written if this were or instead of and? What would you have written as the final answer? Assuming we're changing this into or. What will you write?
Negative, or parenthesis negative infinity,
Comma.
comma infinity, parenthesis.
No, because I can't include something I don't have.
Oh,
So it will be -2 union 5 to infinity. Yes, perfect. Okay. Do we need more examples? Do we need more examples? Are we okay? Okay, so let's see. I have 2 applications here of compound inequalities. Extremely, extremely important. And one of them is for your grade, for example. So let's start with that. Let's say 93. On page 559. Grade in any class. So let's take a look. Christian has scores of 68, 65, 75, and 78 on his algebra tests. Use a compound inequality to find the scores he can make on his final exam to receive a C in the course. The final exam counts as 2 tests. Final equals 2 tests. And a C is received if the final course average is from 70 to 79. I'm writing myself a note. Course average between 70 and 79. So let's read the problem one more time. Make sure I have my notes in order, and then we'll think about it. So he has 4 scores, 68, 65, 75, and 78 on algebra tests, and we're asked to use a compound inequality to find the scores he can make on his final exam to receive a C in the course. The final exam counts as 2 tests, and the C is received if the final course average is from 70 to 79. Okay, so I recommend, can anyone suggest anything, first of all? Okay, before we even talk about this, if I say to you, I have in my pocket an unknown number of dollars, but I know that I have somewhere between $2 and $10. I don't know how much I have, but I know I have between $2 and $10. And I'm going to ask you, give me a compound inequality that represents what I just said. I don't know how much I have, I don't want to look, but I know I have between $2 and $10. How, yes, please.
Brackets 2, brackets 10.
That's not inequality. So I want to express between $2 and $10. So forget about our problem for a moment. I need to express this in mathematical terms. Based on what I just studied, I like to represent between $2 and $10 in mathematical terms.
2 is greater than or equal to x.
So you mean 2 is
Less than.
less than or equal to, excellent.
X.
Yes?
Then it's greater than or equal.
It cannot be. So we cannot have this. This situation is impossible. I can have this or I can have this. This, never. Okay? Or this, never. So I can have this direction or I can have this direction. So,
X is less than or equal to 10.
very good. So that's exactly what we expressed. Now, this was just a little reminder for this. So now I want the course average to be between 70 and 79. So how do I write that? Forget about the course average for a moment. Just, I'm going to say course average. Course average. We are told the course average is between 70 and 79. How do I write that?
70 less than or equal to x less than or equal to 75.
Good. Now let's talk about the course average. So I have two numbers and I want to determine their average. How do I determine the average of two numbers? Add them up and divide by 2. But here, let's count how many numbers we have. 1, 2, 3, 4, 6. So the course average has to have something over 6. Okay. Now, what do I have at the top? What will you tell me to write? For the top, that will be divided by 6. Of course, you have to have 6 numbers. So can anyone dictate? Yes? 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 Plus? Excellent. Because the final exam counts as 2x, as 2 test grades. So I have an x plus another x, that's 2x, and then 4 other test grades. So a total of 6 grades divided by 6, that will be the average. Now I know how to solve this. I just practiced a few minutes ago. This is a compound inequality. So I came up with a compound inequality as they requested in the problem. And now I know how to solve it. Of course, I will have to do what first? Yes, I will use just one number. I don't need 4 numbers. So when you add them up, what do you get?
286.
286 divided by 6, 79, and 70. Perfect. Okay, how do I solve? Yes,
Where do you get the 6?
I'm sorry.
The 6.
1, 2, 3, 4, 5, 6. The average of 6 numbers. So how do I proceed? Everything by 6. So I multiply the left-hand side by 6, the middle by 6 over 1 because it's easier to see what I have to do. So I have 420 less than or equal to 286 plus 2x less than or equal to, if anyone can give me 79 times 6.
474.
Oh, okay. Okay, what will be the next step? Subtract first. Yes, it's not a mistake, but I recommend subtract 286 first. So, in the middle I have 2x. 286, I have, what is it, 130.
134.
Oh, the left-hand side. Or I was looking at the right-hand side. So that's 8, and that's 8. And is it 1? 188?
Yeah.
Good. So 188. Very good. And now we do what? Yes, now we divide everything by 2. And we get what? Is it,
67.
yes, it is 67. And x, and then this is 94. Okay, very good. So what will you tell your friend, if he's your friend or she's your friend, what will you tell him or her?
They have to score between 67 and 11.
Make sure that you get on the final exam. That counts as 2 tests. Make sure you get on the final what?
67.
Between 67 and 94, and you're definitely guaranteed a C in the class. Any questions? Okay, with the same compound inequality, I would like to look at 91. So this is how you figure out. This is one option, depending on the test, depending on the grade distribution or how the score is calculated, and so on and so forth. So if this is the scenario, this is how you determine what you should get on the final exam in order to get a C in the class, if the score or the grade is calculated this way. So let's look at the formula for converting Fahrenheit temperatures to Celsius temperatures is C in Celsius equals 5/9, and quantity F minus 32. So this if I have Fahrenheit, I can determine Celsius, and vice versa. If I have Celsius, I have to solve for F and find the degrees of Fahrenheit. So during a recent year, the temperatures in Chicago ranged from 29 degrees Celsius to 35 degrees Celsius. Use a compound inequality to convert these temperatures to Fahrenheit temperatures. So I'm told that the temperature in Chicago was between, or it fluctuated between, -29 degrees Celsius and 35 degrees Celsius. So we want to start with something, and at the end of the day, we want to find something like this. So I'm told the temperatures in Celsius varied between -29 and 35. They're exactly like me saying to you, I have no idea how much I have in my pocket, but for sure between 2 and 10. But I don't know what it is. But definitely between 2 and 10. How do I write that? This time we are told the temperatures are between -29 and 35. How do I write that? The temperature in Celsius is, so -29 less than or equal to, and 35. Very good. What do I do next? So I established that that's the inequality, the compound inequality. What now? What do I have to do next? Exactly. Exactly. C is this. I have to have F somewhere because I want to get F at the end. Absolutely. Thank you. So -29 less than or equal to 5/9, quantity F minus 32 less than 35. And this is very important now, to know what to do with that 5/9, which we did when we started today with those fractions. So I really want to get rid of 5/9. So what should I do to all 3 sides, because it's a compound inequality, in order to eliminate that 5/9? Both sides, all 3 sides by Careful. So if I want to get rid of 2, multiplying by 2 will not eliminate 2.
Multiply by -9.
Multiply by the symbol.
Exactly. Multiply by 1/2 will get rid of 2. So if I want to get rid of 5/9 and get 1 at the end of the day, what should I do to, or what should I multiply by? Exactly, 9/5. Because these go away, and I get 1. So 9/5 on this side, 9/5 in the middle, and 9/5 on the right-hand side. So what is left in parentheses, or I should say, what is left in the middle? Indeed, that's what we wanted. We wanted to eliminate and just have f minus 32 in the middle. Now the right-hand side, remember this is 35/1, and I will simplify by 5. What do I get? Very good. So the right-hand side is 63. What about the left-hand side? Here I cannot simplify. So I will just multiply 29 by 9. I got -261 divided by 5. Okay, final step. What should I do? What am I adding?
32.
Yes. So I have -261/5 plus 32. What is left in the middle? Perfect. And when I add 32 to the right-hand side, I get 95. Now I would like to talk about the left-hand side because it involves adding fractions, and then that's where some students, not all, have some difficulties. So I cannot add 2 fractions if they don't have the same denominator. The least common denominator is there is only 1. This is 1, so this is 5. So -261/5 does not, as a numerator, does not need anything because these two are the same. But I'm changing 1 into 5, meaning I'm multiplying 1 by 5. So I have to do the same thing to the top. And that's just a reminder. It's not a fraction line. It's just a reminder. Hey, don't forget, 32 needs to be multiplied by 5. So then I have -261 plus 5 times 2, 0, I carry 1, 15, 16. So -261 plus 160 is -101. So this is -101/5. Because it's about temperatures, I will divide and write it as a, not leave it as a fraction. So this is -50, right? 2, I'm sorry. To 0.5 degree Fahrenheit. And I'm going to write it here as well. So F is between -20.5 and 95. And nobody said anything. You're not supposed to say anything. No, I'm just kidding. I wrote 5 instead of 2. So -20.2 and 95. And this is it. And this was very nicely done with the use of a compound inequality, starting from the beginning. So coming back to I still have 5 minutes. Coming back to our syllabus. So we did finish 2.8 and 9.1. I strongly recommend read them. Watch the videos. I have the old ones. Hopefully, I'm going to have something to post from today. And of course, I will post the lecture notes. So that's one thing I wanted to say. Be prepared. Let me see if I got an email message from Kathy. That would be fantastic. She's the best. She's the absolute best. Okay, here it is. I still have 4 minutes. Sorry. I need to show you something, so I don't forget, and I also bookmark this, assuming it's gonna happen today. Ah, wonderful. Potentially, you will open today. We hope. So other than where to put the page numbers and how to get to the multimedia library, is there anything else that I need to show you? Okay, till it opens. So it's, if you want to write it down, and I will put it down on my syllabus from now on. So it's www.accmylabsplus.com. Okay. Okay, so everything is frozen here. Well, at least I tried. Well, I can't show you anything, as you see. Sorry about that. But please remind me on Wednesday. I'll start with this. I'll have it uploaded and everything, so for you to see it. And I'm hoping that you're going to use it. Again, I don't want you to pay more money. We can, handle everything without extra cost. But I think it's a good tool. Some people like it, some people hate it. So thank you for coming. If you have any questions, please stay. I'll see you on Wednesday. Expect a quiz from everything we studied today on Wednesday, and so on and so on and so on and so on. I'm sorry? The class quizzes? Yeah, right here.
So we have a quiz every day, right?
Mostly, yep. Except when it's except when we have a test
Quiz next class.
every day. Yes, except when there's a test. So quizzes are in class, 10%. Yes. I'm sorry.
To at least close down the page and get that clear.
But I just rebooted the whole thing and it still didn't.
Oh, never mind. Or is it closing?
Yeah.